Okay, so we're going to fill out a couple more parts of our foldable. The first part we're going to fill out is ideal gas laws, and then the next part is going to be Charles. So first, open up your foldable to ideal gas law. Okay. In the top, you're going to write the formula for ideal gas law. So this formula consists of pressure times volume is equal to the number of moles of the gas times the gas constant times temperature. Okay, so again, N is the number of moles, R is equal to the gas constant, which for ATM, for atmospheres, it's going to be 0.0821 atmospheres. For kPa, it's going to be 8.31 kPa. And for millimeters mercury, it's going to be 760. No, sorry. It's going to be 62.4 millimeters mercury. Okay, so first, let's go ahead and we'll do a quick example. Go ahead and write the variables over here for pressure, just in case you're not sure. Pressure. Okay, volume, of course, and T is temperature. And that temperature will be in Kelvin. Volume will be in liters. So let's do a quick example. So let's say you have a volume of gas at 6.3 liters. You have 9.7 moles of that gas at a temperature of 350 Kelvin. What is the pressure in atmospheres? Of course, we'll be using the gas constant 0.0821 atmospheres. So we put into our formula, so here's our formula, PV equals nRT. We're looking for the pressure, 6.3 liters is our volume, 9.7 moles, 0.0821 is our gas constant, and our temperature is 350 Kelvin. So we go ahead and multiply these across, which would give you 278.73 equal to P times 6.3. Of course, then you would divide by the 6.3, which would give you a pressure of 44.243 atmospheres. And that's that. You just plug each one in and multiply and divide. So a second example, move on down here to the bottom. We have a pressure of 607 kilopascals, a volume of 37.2 liters, temperature of 652 Kelvin. We want to know the number of moles of this gas. And again, for this one, our gas constant will be the 8.31 kPa. So again, we start by consulting our formula. Go ahead and start plugging in our numbers. Our pressure our volume. We don't know the number of moles, our gas constant, and our temperature. So now that we've got everything plugged in, we go ahead and multiply across and divide. So we have this and this, that multiplies to 22,580 equal to N. Multiply these together, and that gives you 5,418.12. Okay. Now we go ahead and divide. We end up with 4.168 moles of the gas. Easy peasy. What you might want to do is go back through and just kind of indicate to yourself the units. So just kind of take a look at the units. So we can see the units here, Kelvin, that's our temperature. We can see our volume is liters. We can see our pressure is atmospheres. Okay, that's what we're looking for. So just, color code if that's helpful to kind of help you pay attention to the units and see what you have, see what you're missing, so you know how to solve. And volume, temperature. Okay. So go ahead and flip to the Charles's Law section, and we will fill out this Charles's Law notes. Okay. So Charles's Law can be solved in a couple of ways. It can be written as V1 over T1 is equal to V2 over T2. So that's volume of the first gas, or the first volume of the gas over the first temperature of the gas is equal to the volume of the second volume of the gas over the second temperature of the gas. Or it can be written as volume 1 times temperature 2 is equal to volume 2 times temperature 1. So either way will get you the correct answer. And I'm actually going to show you both ways. So here's our problem. Let's say we have a balloon and a hot car. That car is about 400 Kelvin. And it holds about 2.7 liters of a certain gas. When the balloon is put in the oven, at 650 Kelvin, how much volume will it hold? So we are looking for the volume. So we can let's just take a look and underline what we have. So we have temperature. This is the first temperature they give us, so we'll label that as 1. We have a volume. This is the first volume, so we'll label that as 1. We have another temperature, and it says when the balloon is put into the oven. So this is after something has happened to the balloon. So this is temperature 2. And then we are looking for volume 2. So it always helps to go through word problems and kind of label things, label the units so you can figure out what you're supposed to do. So let's go ahead and take a look. We'll solve using this version of the formula first. So we'll go ahead and plug in volume 1, 2.7 liters, divided by temperature 1, 400 Kelvin, equal to volume 2, which we don't know what it is, over temperature 2, the 650 Kelvin. So again, it might be helpful to just color code your units to help you pay attention to that. So now we just cross multiply and divide. So 400 times the V2 is equal to this times this, which gives you 1755. Now we go ahead and divide by the 400. And we get a volume of 4.39 liters. So that's volume 2. Now to show you the other way, we'll move up. So now we'll look at this version of the formula. Okay. Again, we'll plug in volume 1 is a 2.7 liters. But this time we put with it temperature 2, so 650 Kelvin. That equals volume 2, which is unknown to us, times temperature 1, which is the 400 Kelvin. Then of course we multiply. This is 1755 like it was before. Then divide by the 400. And you can see we get the exact same answer. Okay, so that, like I said, was ideal gas law and Charles's law.